Welcome back to the functions unit. Today we're going to be continuing the functions unit by talking about graphing linear functions. So let's go ahead and take a look at example A. So here we are at example A, and it says, given the linear function, complete the table, then use the ordered pairs to graph the function. So the first thing that we need to understand today is everything that we're going to be talking about is a linear function. That means that every equation we use to make a graph is going to create a line. Now our equation, y equals 2x minus 4, remember that x is going to be our input and y is going to be our output. So we need to select some inputs to input into our equation to give us outputs and create ordered pairs. They've given us one input, which is 0. We're going to choose other inputs. I'm going to choose one negative, one positive. You can select any inputs you want. But notice that our graph goes between positive 10 and negative 10 on all sides. So you should not pick any numbers that aren't going to be between negative 10 and 10 because they're not going to be on our graph. Now that we've talked about what type of inputs to pick, let's actually choose some inputs. So I'm going to choose one negative and one positive. My negative is going to be negative 2. My positive is going to be positive 3. Again, you could pick any input that you want. As long as it's between negative 10 and 10, you have an excellent chance of it ending up on our graph. Sometimes when you substitute numbers in, they won't always end up on the graph, in which case you'll have to go back and pick another number. So let's start with our substituting of negative 2. In order to do that, we're going to be plugging it in for x. So 2, plug in our negative 2, minus 4, and then we're going to be applying the order of operations. So down here at the bottom, I'm going to use my order of operations. 2 times negative 2 is going to give me negative 4. Negative 4 minus 4 is going to give me negative 8. So my output is negative 8. Now I'm going to substitute in my 0, and I'm going to see that that also works using my Desmos calculator. So if I bring my Desmos calculator in here, I'm going to be plugging in the things that I need in order to substitute in. So I'm going to put in my 2, I'm going to put in my parentheses, I'm going to put in my 0, close parentheses, and subtract 4. If I do that, I can see the calculator does the order of operations for me and gives me negative 4. And I could check that to make sure that it's right. 2 times 0 is 0. 0 minus 4 is negative 4. So yes, my calculator is doing that correctly. So I know that my answer to that is going to be negative 4. Now let's take a look at positive 3. So again, I'm going to substitute in. I could use my Desmos calculator, or I could do it in my head if I think I've got it down. I'm going to show my work either way. 2, plug in my 3, subtract 4. 2 times 3 is 6. 6 minus 4 is going to give me positive 2. And now I have all the points that I need to plot on my graph. So now that I have my points, let's go ahead and do that. For my first point, I've got negative 2. So I'm going to go over to negative 2, down to negative 8, and plot my point. Then I'm going to do the same thing with 0, which is right here. Go down to negative 4. This is, of course, the y-intercept because this is where the line is going to cross this y-axis. And my last point is going to be over to 3 and up to positive 2. And I can see that all of the points that I picked have made a straight line. So I know that I've made a linear function. If one of my points was way off the other two, I would know that that one was a mistake, and I need to re-substitute in my input, run my equation again to see if I can get a different answer. So now that I've got them all there, I'm going to connect them because remember, these are not the only points that are going to work for this equation. These are just 3 that we happen to pick. Any number that we pick and substitute into this linear function will fall on this line. We just happen to pick these 3, but any number we pick along the line would work. So we need to indicate that by drawing a line all the way through our graph to connect all of our points. And then, because these aren't the only numbers that work, they just happen to be the ones that are between 10 and negative 10, we need to have arrows at the end of our graph to show that we can have any point going on forever. Now let's take a look at example B. So here we are at example B, and it says, given the linear function, complete the table, then use the ordered pairs to graph the function. Again, we're talking about linear functions, so everything we're going to use today is going to make a line. In this case, my linear function says y equals 1/4 x plus 2. So any number that I substitute in, I'm going to be multiplying by 1/4 or dividing by 4. It's the same thing. To help me out with that, there's a little trick I should remember anytime that my coefficient is going to be a fraction. And that is that anytime that my coefficient is a fraction, I should choose numbers that are divisible by the denominator. I could pick any number I want, just like I did in the first example. However, if I pick numbers that aren't divisible by that, I'm going to end up getting decimals. I'll give you an example. If I were to choose 3, I could substitute it in. 1/4 times 3 plus 2 would give me 2.75. Can I graph 2.75? Absolutely. Is it the easiest number to graph in the world? No, it is not. So I'm going to pick numbers that are divisible by 4 because they're much easier for me to graph. So in this case, I'm going to choose again 1 negative and 1 positive. My negative in this case is going to be -4, and my positive is going to be +8. So again, we're going to start with our substitution. Again, you can use your calculator or you can do it in your head. We've got 1/4, substitute in -4. We should show our work either way, plus 2. So now if I do 1/4 times -4 or -4 divided by 4, it's the same thing. I get -1. -1 plus 2 is going to be +1. Now I'm going to plug in my 0. So I'm going to have 1/4 times 0 plus 2. And again, 0 being very easy to work with. 1/4 times 0 is 0. 0 plus 2 is 2. And then finally, I'm going to plug in my 8. 1/4 times 8, so 1/4 parentheses 8 plus 2. 1/4 times 8, or 8 divided by 4 is going to give me 2. 2 plus 2 is 4. And I've got all the points that I need for my graph. So let's go ahead and plot them on there. So I've got -4, so I'm going to go over to -4 first, up to +1. Then I've got 0. Again, this is going to be my y-intercept because it's going to be where it crosses the y-axis. So 0, 2. And then the final point of my graph is going to be way over to 8. So I'm going to go all the way over to 8 and then up to 4. 1, 2, 3, 4. And again, you can see that my points make a straight line. It's a steeper. This line is a little bit flatter this time. That makes sense because that my coefficient is a little bit less than the one that I had before. Remember, my coefficient before was 2. This one's 1/4, 1/4 being smaller than 2. So I'm going to get a little bit flatter line. So now let's go ahead and connect all our points. And remember, we're trying to go all the way through the graph with our line. Doesn't have to be perfect, but we're going to use a ruler or straight edge. In this case, we're going to now align this up. We want it to go all the way through the graph, all the way through our points. And then once we've done that, we're going to make sure that we connect all of our points and have arrows on the end of our line. Because remember, this can go on forever. These aren't the only possible choices. They're just the ones we picked. Now let's go ahead and take a look at example C. Here we are at example C, and it says given our linear function, complete the table, then use the ordered pairs to graph that function. And again, since we're talking about linear functions, we know that our equation is going to make a line. So now we've got a different type of looking equation here. This one says y equals -2. There's nowhere for us to plug in an x. But this is actually making this a lot easier for us. Because if our equation is y equals -2, that means that every single time our y is going to be -2. This time it'll be -2. The second time it'll be -2. The third time it'll be -2. The 12th time it'll be -2. So it does not matter what inputs we choose because y is always going to equal -2. So let's choose a negative just like we've always done. So -3, and let's choose a positive, +6. So now let's see what kind of line that we come up with. We don't have to do any substituting. We don't have to take out our calculator. We just have to plot our points. So our first point is -3, -2. So we're going to go down over to -3, down to -2, and plot our first point. 0, -2, and our final point at 6, -2. So notice that anytime our linear function is just y equals without any x, the type of line that is formed is a horizontal line. So we're going to, again, connect all of our points because, again, these aren't the only points that we picked. They are the points we picked, but they aren't the only ones available to us. And we're going to have arrows on the end because this could go on forever and ever. But notice that we've plotted a different type of line from the ones we've had before, but it still created a line. That brings us to the end of this set of notes and this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.